Okay, so this is a question about resistance, electromotive forces, powers. So part of this is to find the resistance. So resistance is, in general term, how much an object impedes a flow of electrons through it, but from a more practical point of view, it's the ratio of voltage applied to a circuit element to the current that flows through it. R equals V divided by I. Right, potentially for non-ohmic things, R can be a function of V or I, or both. Ohm's law is for ohmic devices like resistors. That ratio is fixed. V equals IR, and I is a constant for the device. So for this question we have resistors, 2 ohms plus or minus 10%, as long as we're in 3 watts. Right, so what we need to do is worry about what's the maximum current, what current will give us 3 watts. And we need to take the worst case scenario of the minimum resistance, which will give us a maximum. I max, you see, R min is on the denominator there. So the minimum resistance is 10% less than 2, 1.8. You put that in, we get a maximum current of 1.29 amps. So EMF, electromotive force, that's the potential given to charges in a voltage source in a battery or that drives a current around the circuit. So in part E, we're going to analyse this circuit. Right, we're going to consider 2 resistors. These resistors, there's a low end resistance and a high end resistance. We'll see which one has the most power. So our power formula, P equals V squared on R. Right, that's the most useful one because we have V, we have R. Right, our maximum power will be for our minimum resistance, for our 10% low. Similarly, our minimum power will be our maximum resistance. We've got 2 resistance series, 10% low 1.8 plus 1.8 gives us 3.6. The VET high 2.2, with another 2.2 in series gives us 4.4. Obviously our ohms. Right, so we find our maximum power, our minimum power. Our maximum power output is 8.2 watts. Our minimum power, wrong way around. 8.2 watts minimum, 10 watts maximum.